what is the Net Promoter Score methodology? If you don't know it, it was published 2003, about 14 years ago in the Harvard Business Review, under the title, "The One Number You Need to Grow," by Frederick F. Reincke from Bain Company. And it is basically a rolling survey design with two questions that is constantly being evaluated. And what are these two questions? The first one is, would you recommend our company, or product, or service to a friend or colleague? And on a scale to 0 to 10. And the second one is, please, why did you give that rating, and let us know how we can improve it. And nowadays, you very frequently encounter that if you buy an airplane ticket, or after you flew, or you were in a hotel, or you booked a hotel somewhere, you get an email afterwards to rate, and you get these smileys, 1 to 10. That is basically not exactly that, but it's very similar. After a business transaction, you are being asked to evaluate how it was and whether you would recommend the company. The second answer is basically free text with the reasons to the answers of question 1. And the whole design, if it's actually done by telephone or live, is done that it lasts less than 2 minutes. Think about it, it's 14 years ago, social media were not that developed at that time. I mean, Facebook was founded 2004, yeah? And same with Twitter and so on. So this was pre-big data, let's say like this. And so these interviews were designed to be actually done by telephone. And quite a lot of companies do it still nowadays through their call centers by telephone. But are these two questions and monitoring those questions really enough? Well, let's first have a look a little bit more detail into the answers. The answer to question 1, this rating, provides information on the customer satisfaction, customer loyalty, repurchase intention, and of course the recommendation probability. And the answers to question 2, they actually show what were the customer expectations, the needs, and the real customer experience that it had with the company's products and services. And that can be quite interesting. How do you calculate from the rating now the Net Promoter Score based on this methodology? Basically you look at percentages. Here we have a distribution of rating from 0 to 10, and we have, for example, 28 people who answered 10, 37 answered 9, and so on. And according to this methodology, 9 and 10 are the promoters, and you calculate the percentage of all who voted 9 and 10. These are the promoter. And on the other hand, you look at the scale 0 to 6. These are the detractors that actually do not really recommend or actually harm your business. And you make the difference, the percentage of promoters minus detractors. Here you have the example, 58% are promoters, 5% are detractors, so 58 minus 5% gives 52. That's basically the way it's calculated. You can work with this percentage score or even with the scale, which we'll do later. Now, how about the promoters? What are they doing? They are sitting somewhere in the world. They might be your brand evangelist. That means they talk to their friends, neighbors in the family, and say, oh, listen, I did this, what really good, try it out. And maybe you know this picture with the Facebook connection of everybody who's linked to whom in the world. This is not really new, but Facebook actually provides a platform through which you can actually recommend with a like button things to your friends and so on. And if you look at the rapid growth that the company had since 2004, the idea this article published 2003, before Facebook was founded. Facebook probably never applied the Net Promoter Score methodology in its pure way, was that high Net Promoter Score translates into high customer recommendations, that will increase your customer recruitment, and that will create growth. And that's the title. The one company, the one number you need to grow is the idea behind the Net Promoter Score. Okay, but we are talking not just about this number, this recommendation number, but also about the answer to question 2, the text. And this is a typical base table of analysis. If you do a Net Promoter Score project, you have some information, the date when the person answered it, you have the rating, and you have the answers to question 2, why the people gave this rating. And in general, if you do it wisely, you have also some additional information on the last interaction that the customer had with your company, whether he called in the call center, or he bought a product of a specific type, or he was a customer service unsatisfied, and so on. So you have some additional information, and now the idea is how do we actually analyze and make sense out of this answer to question 2. Well, I did this, I'm working 20 years for SAS, so I did this with SAS software. This is called contextual analysis, but you can do it with other text analytics software, of course. I know very good how to use this, so I show you how this works with SAS. So first you basically enter the table, project name. You have to decide on the language, because you have to use the NLP functionality of a specific language in order to reduce in stemming into the infinitive of verbs and so on. And then you apply stop words in this language. These are words that are very frequent and they don't add a lot to the sense. So you want to eliminate them from the analysis. And then basically you decide the data source. Here I put again the table, and we give the text variable the role of text. So this is going to be analyzed. If you have additional category variables, like here the location from the person, which type of seat he booked, these are airline booking data, or in which class he was, you can use that actually as category variables. They are also sometimes enlightening later. All right. So the last then is you let it run. It runs automatically. You see basically here when it ran, how much time it took. You see how many documents, how many texts were analyzed. You see how many different terms are in there, and here you see the run status, whether everything was okay or whether you have problems, then you get a red cross here. Well, the first thing is you can go into the view of the terms, which are basically the words that are used, and you have here on the right side the dropped terms, those terms that are not going to enter the analysis because they are on the stop list. They are very frequent. Remember, we had less than 1,000 documents, and the word to be and to have, they are in every document, so it's always good practice to have them on the stop list and to neglect them. If you see other words here on the left side which you want to move on the right, you can do that. And you see also here that you can actually open up those black boxes, and you see the different kind of versions of declinations of one word that are mapped into one term on a top level. There's also spelling correction. If you want, you can use that. There, I would always say, one should use this if you are working with dirty text. Dirty text for me is if technicians enter text in a workshop and they have their own abbreviations. If it's like this, people from the call center entering text in general, it's not so bad, but also there you have to sometimes to look whether you have to correct the spelling. Well, we saw these customer, delay, and food as issues that were very frequently mentioned in those texts, and we can look at the term map, which shows you here the associations with other words with which they are actually occurring very frequently. So you get already some indication where you're going here. For example, food with comfortable, choice, incredible, hungry. Yeah, maybe they didn't get food on some flights. But this is just a first view on what is in those texts, and you can actually look later after you did the analysis and you found some interesting terms back to those term maps to analyze those. In the beginning I just showed this here as some functionality. And then you have here again these terms sorted based on the frequency, and you see you can go here on the Documents tab and you see where these words appear. This is just the word flight. Of course, if this is airline data, the word flight probably should be even in the stop list. I wouldn't even use it. But I left it in here for purpose of just to have something to show where you see lots of occurrences. Well, if I look at these terms, I could actually create a variable for each and any term that I have here. Now, for example, here, flight, fly, time, hour, seat, and so on. These are basically those terms. If I number them, and I would create a binary variable for each term, and we had more than 2,000 terms, which is not a lot of terms for text analytics project in general. You have much more terms. Then you would get a humongous base table for analysis with binary variables with lots of zeros in there, and the more rare terms, they have only very, very few ones in there. So this is not very efficient information. What can be done is you can actually factor this and combine terms. And there's a way that is used in text analytics is the singular value decomposition, which basically takes these Word document matrix and tries to combine terms in less variables, factors it and looks at those terms that are best approximating the entire matrix. And you approximate then this matrix in a dimension k, which is much less than m, the number of original terms. And I applied it here, and here you see we are getting actually 9 topics, 9 such singular values. And I want to explain this with image processing. If you have a picture, I mean here this is a beautiful picture of Bern, but if depending on what you want to actually distinguish, the mountains from the hills or the city or certain types of buildings, you would not take the picture with the best resolution with each and any term, but you would actually take some averaging. Here this is Gothic Church Notre Dame in Paris, and dependent on what is the best resolution for the purpose of distinguishing the items in your text, you take a different resolution. And that's what the singular value decomposition does. Here in this case, we find a 9-dimension for this document collection enough and optimal, and it does it automatically. But this is a very exciting part of the analysis always, because in each and any text analytics project, you get different singular values and different terms that actually set up those singular values. And that's basically the discovery in the text that you make. Well, now if you are within those dimensions, you can actually even move a little bit more around. And again, I explained this based on pictures. Yeah? Here this is in Berlin, the Brandenburg Gate, a snapshot. But if I want to see these two canonical axes and get an interpretation here, well, this is kind of like the height of the building and this the width, but it's not really correct because it's a little bit backward. But if I would go and move a little bit around and put myself in the correct axis, I can actually now interpret the two axes as height and width. And to go back from the singular value decomposition to the text topics, I do an orthogonal rotation in those space in order to map the terms in the k dimensions so that on each of the k dimensions I have a term with a maximum coordinate. In all the other 8 axes it has a minimum coordinate. And here again the picture, these are my original singular values f1 and f2, and I have terms, they are somehow dots in the space, and now I'm rotating my axis orthogonally so that some terms have a very, very high coordinate on one axis and a low on the other. No? And the same with these. Of course, some of the terms they are in between, they will be dropped. They don't help to interpret those topics. And from here, I say this axis here is basically x1, x2, x3, and I can just say, okay, let's assume this is here line, check, back, agent, gate, and here it's Delta, Atlanta, JFK, Detroit, Las Vegas, and this is a way how you get actually some interpretation into the numbers that are derived from the singular value decomposition that you can interpret. Well, so I explained now how you get the labels, how you get the number of singular values, the number of topics, and then you can look actually how many documents you have within each dimension. And here I took the first one, cancel, delay, united, day, next. Yeah? So you can already interpret here. These are people who are upset because their flight was delayed or cancelled and they had to fly next day or next flight. Actually these are only the first terms. There are more terms, and here is the weight, basically the coordinate from this axis. Here you can actually look also at it in a word cloud, where basically the size of the document is mapped. Sorry, the size of the weight is mapped to the term, I can actually here then go onto the document view and I see which terms are actually connecting the topic, and I see here the relevancy with which percentage I am in this document. If I want to read the entire document, I have to go on one of these tabbers here, and then I see only one document per page because the text is longer. Well, how about these smileys? This is an automatic sentiment analysis. This is independent from the text topics and singular value decomposition. Behind this is a term model with adjective, adwords, and phrases with positive and negative weights attached to them. They come out of the box with our software. This is basically the intellectual property of our software in all the languages that support the analysis. And in this way, you have an additional view to interpret those topics. Of course, I mean, cancel, delay, and so on. 89% of those people who are in this topic with their comment, they answer very, very negative. That makes sense. Then we have the second topic, good, friendly, true, comfortable, great. You have always people, and in general there's also mentality problem between Americans and let's say Germans at least, maybe Swiss also, they're more critical. Yeah, Americans are always, if everything is, if there's no problem, they're always, it's great, it's positive. Germans would say it was okay. Yeah. It's always interesting because I'm engaging a lot of projects for German companies, manufacturing companies. They export all over the world, and they have to do it in all the languages. And then we have to kind of align these things, even between British commands and US commands, and we cannot do them at the same time because they need some additional interpretation. It's always interesting to work with the colleagues and together from Great Britain, from the US, and engage in those discussions, or in Australia also. Okay, that's the sentiment. So this is basically a description of your data set, and you can already see, well, here you have a big issue, but then more interesting is this interaction here, where you see also some other critical topics: line check, bag, agent, gate. So this is a problem with the luggage process. Yeah, either you're very long in the line, or your luggage gets lost, and so on. Well, now this was the interaction between the inbuilt sentiment model that SAS provides with its software. But how about the Net Promoter Score? Let's go back to the introduction. We have this number scaled 0 to 10. And is there an interaction between the text topic and the Net Promoter Score? Because if we find none of the text topics is significant to explain the Net Promoter Score, we shouldn't engage in text analytics. And we should stop. So we have here a process of evaluation. The output is the rating. We have some controllable factors because it was asked which airline were you on, which date, which location, which cabin did you fly. So we could actually eliminate also certain of those dimensions, saying, okay, let's just look at Lufthansa, United, or I don't know, Southwest Airlines or something like that, and do the analysis on this. These are controllable factors. Then we have the text topics, their input, and of course we have uncontrollable factors which we don't know about. Maybe there was a bad weather or a storm or some other incident, and so on. So the idea is to estimate a functionality between these variables here and the output Net Promoter Score, or the rating. So let's have a look at the analysis table now. This was our original text. This was the rating. These were the categorical variables that we had actually from the survey design. We knew the airline, the date, the location. And here are our text topic variables, which are attached now to every document with basically the sum of the weights of the words that are up here. And so you get these numbers, and now we have a linear, or let's say a structured problem, where we can just estimate the functionality between these variables here and the rating. Yeah? So this is our objective, the rating. And of course, since we have also some additional variables here from our survey design, well, let's also use those, because we want to prove that the text topic help in interpreting this data. And if I find a model where the text topic are significant, then this shows that I have actually gained some information. Okay, so these are the inputs, controllable factors, the rating, and this is what we want to estimate, the functional thing. And with SAS, you have prog reg for a linear regression. You say this is what you want to estimate, and this is your model. Topic colon means it takes topic 1 to topic 9, so it's just a concatenation. and takes also these other variables. However, these other variables are categorical, so they wouldn't work with a linear regression. For that purpose, we have to do general linear model, GLM, and we also do a variable selection in order to figure out which are actually the significant variables, because I don't want to have a model with variables in there that are not significant. Then on a stepwise process, you can see how the coefficients develop over time, and error goes down. And here is the final model, and we see in the final model these are the significant topics. From the 9 topics, only 4 are selected. However, okay, we knew the first one was cancelled flight, yeah, and the second was everything is great. Yeah, everything is great does not really help to explain the Net Promoter Score. But here we see that the topic number 9 has a very, very high negative coefficient. And now to come back to the title, how to find out improvements based on data mining, you can select basically the issue of topic number 9, because this has the largest impact in your model of explaining the Net Promoter Score to improve the situation for your company. Okay, this is here the topic number 9, and I looked at it in a little bit more detail. These are people who kind of booked, and they thought they have a seat and they can actually get it fixed, but actually just at the gate they have to pay again to get the seat. Yeah. Of course they have a seat, but otherwise they would have to get in as the last person. Anyway, it was a very interesting result, and I see my time is over here, so let me just, oh sorry. So the process is you look within the regression at the variable with the highest parameter estimate, which is significant, of course must be significant, and from there on basically you can go back, look at the text that is associated with this topic and derive improvement measures. Well, even though it's a very special case, and to my knowledge Facebook did not use it, Facebook provides a good anecdotal evidence of the usefulness of NPS analysis, because the like button is actually an implicit recommendation, and so basically this is the dynamic of Net Promoter Score analysis if you do this for your work in your company or in your assignments. Thank you very much.